In this video, we aim to delve deeper into the shape of profiles by examining two shapes, circular and square cross-section, without the need for any laboratory facilities. The purpose of this simulation is to find a better shape for the Formula student chassis. To achieve this, we will survey a couple of parameters to determine which shape provides more resistance against external loads. In this simulation, we are comparing two chassis with the same characteristics, consisting of the same material, thickness, and length, but differing in shape. To simplify, we divide our chassis into smaller parts to enhance the accuracy of the simulation and reduce calculation processing time. Designing a lightweight chassis is an important challenge always in Formula 1. In the first stage, we will survey the net mass of the chassis. As you can see, the chassis with a square cross-section weight is approximately 10.5 kg, whereas circular chassis is 9.7 kg, which has more mass and a surface area compared to the circular section. However, the difference in mass are less than 1 kg. That is negligible in this case, but it could be important in complicated structures. Nevertheless, we agree that circular pipe yields a lighter chassis compared to square tubes. In the second stage, we will survey buckling resistance. We examine our profiles in an Ansys explicit dynamic environment because we aim to simulate real crashes over the time. We set the collision velocity to 50 meters per second and intervals of 0.005 seconds. For this purpose, I know it's a very small interval time because we want to survey the end of the crash frames. We assume our elements act as a single column subjected to axial force. As shown in the table, we assume our column is in a fixed free position colliding with a rigid wall at the velocity of 50 meters per second. The result, as depicted in the bottom left diagram, shows that the circular profile exhibits more deformation compared to the square one. This indicates that the square profile has a more resistance against axial or buckling loads. In the third stage, we will survey bending resistance. To clarify further, we exaggerate our scale to determine any significant discrepancies. As you can see in the bottom left diagram, the circular pipe experiences more deformation compared to the square pipe, indicating that the square shape has a greater bending resistance. In this examination, we are not investigating this reason for the impact. In other words, we assume our beam is supported on both ends and the load or force is applied in the middle of the beam using the highlight formula for calculating maximum deflection as previously done by software. Next critical parameter is torsion, which plays a vital role especially in joining parts where pipes are welded to each other. Firstly, we should understand the crucial factors to calculate torsion. We aim to find the delta, which determines the angle of twist. We will apply the same angular torque to our beam to determine which cross-section has a more fatigue resistance against torque. As depicted in the diagram, the circular profile shows less deformation compared to the square shape, indicating that circular pipes have a more resistance against torsion. In conclusion, we examined the entire chassis in two different shapes, and the final result shows the square hollow beams have a more resistance against deformation. As shown in the diagram, This simulation could be a good starting point for optimizing Formula Student chassis, considering driving safety and examine maximum fatigue for chassis and many things like that. Thank you.